Welcome back. Today we're going to talk about solving quadratic equations graphically. Now we've talked a lot about solving quadratic equations in the last module, and we've done a little bit of solving quadratic equations graphically, so nothing about this lesson is going to be super new, but I will show you formally the technique to do it with your graphing calculator. Okay, so we have a quadratic equation right here, and what I want you to recall is that a quadratic equation is different from a quadratic function because a function relates two variables like x and y, whereas an equation just relates an expression like this to another expression like this. So the method, and you've actually seen this before, the method that I'm going to use to solve it is I'm going to put it in my graphing calculator and I am going to set this equal to y1 and this equal to y2. Okay? And then I'm going to look for the intersection of these two expressions. So let me go ahead and grab my graphing calculator and go into y equals, and I'll put the first one as y is x minus 4, quantity squared, and plus 1. Okay, and I will make the other one equal to 3. Right, I'm going to graph it. So here it is graphed. And I'm going to be looking for the values of the intersections between this constant, this horizontal line, and the quadratic equation. Actually, I can probably do this looking at the table. Let's see, when is the y1 equal to 3? So we see 3, 3, and 5, 3. So it's a fairly easy thing to do. So the x values of 3 and 5 are going to make the quadratic equation equal to 3. Notice the other one's always equal to 3. So the solution set here is 3 and 5. Now, if I wanted to do it with the graph, let's say that they're not integer values, what I would do is I would use the second trace, and I would ask it to calculate the intersection. Now, it's going to go through a series of questions, so it's going to ask me my first curve here, and you want to say yes. If your first curve was somewhere else, you would press the down arrow key to get the first curve. But for me, it doesn't matter. So this is my first curve here. My second curve is y2. And I'm going to guess, I'm going to put the cursor near the first intersection here. So it does come up with a value of 3, 3. And I would do the same thing again to figure out the second one. First curve, yes. Second curve, yes. This time I would arrow to the right to get near the other value here and press. It doesn't have to be exactly on there. It just has to be near it. And we'll pick it up. 5, 3 is the other value. Okay? So the solution set to this equation here is 3, 5. Remember, we would expect for a quadratic equation for there to be two solutions. Okay, another way of doing this is, let's say I have this quadratic equation. So I could very well do it the last way, which is set this equal to y1, set this equal to y2. But another way I could do it is just to take the equation right here and create the equation where 0 is on the right-hand side. So let's see, I have 2x squared. That would be minus 2 is equal to 0. Okay, so what I could do is make this a function by going like this, setting it equal to y, and graphing this in the graphing calculator and asking not for the intersection, but for the zeros of the function. So let's go ahead and try that. So here we want to clear out the calculator. We go to 2x squared minus 2. Whoops, I forgot my x here. If you ever forget something, what you want to do, I think it actually will put it, great, it'll just put it in. Second insert inserts to the left, so that's another way of getting it. All right, let's graph it. Let's check it out. Okay, so I'm looking for the 0. So it looks like it's at -1 and 1. I could always go to my table and make sure. So when the x is -1, the y is 0, and then when the x is 1, the y is also 0. So that's actually my solution set. If you wanted to use the calculator to calculate it, what you do is you'd go second trace, and instead of calculating the intersection, you will calculate what's called the zeros. So you choose option 2. Now it goes through a series of questions that I want to make sure you understand. It's going to ask you a left bound and a right bound. Now the left bound and right bound have to be on different sides of the above. One has to be above and one has to be below the x-axis. So if I'm looking for this root right here, my left bound is going to be above and my right bound is going to be below. So I'm going to use my left arrow key to get this above. Basically, you're telling the computer like you're giving it a range of values, of x values to run through to try to get the y values at 0. So my right side is below, let's press enter there, and guess means you can sort of put your cursor near it, you don't even need to. Okay, so negative 1 and 0 it comes up with, which is good, that's what we got at our table. Let's try it again, second trace 2. And now here, my left bound is going to be about here. Notice it puts this little cursor up here. And then my right bound is going to be about here. And notice it's saying to the calculator, you're going to be checking in between these x values here for a y value of 0. And guess it doesn't really matter, and it picks up that 1, 0. So here my solution set is negative 1, 1. Okay? Let's run through a couple of word problems here. Now here, they're talking about a tightrope walker who's walking on a net that's 20 feet above. So there's this equation that we've seen again with a negative 16 here. And she is walking on a tightrope that's 20 feet above, and she slips off the tightrope and she falls onto a net that's 15 feet below, which means it's 5 feet above the ground, okay? Because it's 15 feet below the tightrope. Now, what you want to know is how long it takes the tightrope walker to go that 15 feet and land 5 feet above. So essentially, you want to know when this function is equal to 5. So negative 16t squared plus 20, one is at a height of 5. So let's go ahead and grab our calculator. So, and let's put in negative 16t squared, or x squared, plus, I don't think it didn't get my negative. So here, to insert something, you go second delete, and that will insert. I want to put the negative there, plus 20, okay? Now I'm going to hit graph. All right, now if I wanted to, I could change my window so my x max or my y max a little bit bigger. I could see both sides. And I don't need to have my x min be like that. I can just change it a little bit. So now I can see it's probably a better way. So it looks like it's about 1 and a little bit more of a second. Okay, so I'm going to calculate the zeros, or actually no, I'm actually want to calculate it when there's a height of 5. I don't want to know when she hits the ground, I want to know when she hits the net. So here it looks like a little bit less than 1. So I'm going to go second trace, and I'm asking to calculate the intersection. First curve, yes, second curve, yes, and I want to pick up the intersection here. We're not interested in the other intersection because we are only interested when the t-value is positive. So here it looks like it takes about 1 second to reach a height of 5 feet, right? And so that's the answer to that question. Okay, finally, we have a model of a dolphin jumping out of the water. And this is the quadratic function here. So here, notice it's a lot like the other one, but it has x here. It does have that negative 16, and that makes sense because that's the effect of gravity on a falling object. And so we're wondering, so the dolphin is sort of jumping out of the water, and it starts at the surface of the water. So here it makes sense that there's an x here because when x is 0, y is also equal to 0. So the height is 0 when the time is 0. So we're sort of starting the clock when the dolphin breaks the surface of the water. We're wondering how long is a dolphin in the water. So this is your time value, your x value. So we're wondering what is the x value of this second root here, and then we'll know the time at which the dolphin broke through the surface of the water coming back down. So let's go ahead and grab our graphing calculator here. What's nice is actually all we have to do is take out this one and put an x on this value. We're all set because it's so similar. Okay, so let's go ahead and graph that. There's jumping up and coming back down. So we're wondering, instead of the intersection now, we're going to calculate the 0 because it's the intersection in the y-axis, and that's a particular type of intersection. So another thing I could do is in y2, I could put y2 is equal to 0 and then calculate the intersection of those two objects, but that's the same thing as going to trace and calculating the zeros. Okay, my left bound is, let's see, where is the cursor here? Okay, this is 2, okay, I actually have to use my left arrow key to get it above the, there it is. Okay, I want my left bound to be here. and I want my right bound to be here. And guess it doesn't really matter. So it gets, so the 0 is at 1.25. So that interpretation is that at 1.25 seconds, the y value is 0. So the dolphin is in the air, it breaks the surface of the water at 1.25 seconds. And that's the end of the lesson for today.